It's important to teach it in context to create a story problem, but also for students to create a story problem, because then that shows that they understand the size and value of numbers and the operation involved.
So they want the students to be able to create a story. So like if we were to give them like a project of like, if we were to tell them to basically write a word problem, is that basically what they want them to be able to do?
I would probably give them I'd probably give them a problem, and they would have to write a story context for that, and then be able to also model the solution.
So for example, if you gave them this, how much chocolate will each person get if 3 people share half pound of chocolate equally? Like if you were to just give them that, you would want them.
No, I would give them.
You would give them
1
3
half
and 1 half
divided by 3.
Oh, you would give them the problem, and they have to
problem.
create a story in context
Yes.
of the problem. So they would have to make up something that has to do with basically taking this 1 half and dividing it up by 3.
Yes.
They would have to understand which number they're trying to divide.
Yes.
Okay. So if I'm looking at the standard, if I circle the verbs, interpret is 1 and compute is 1, and then we have create down here. So they need to be able to not just solve, but they need to be able to interpret the quotient, and they need to be able to solve or compute it. Okay, so they need to be able to.
So the whole interpreting, because once they get a whole number and a fraction, like for example, if you have 10 yards of fabric and you want to make skirts that are 1.5 yards long, then your quotient would be 6 2/3,
which is how many skirts you would be able to make out of the 10 yards, right?
Right, which would be, you can only make 6 skirts.
Because you're not going to make 2/3 of a
skirt. So even for them understanding that it's 2/3 of a skirt, or they have 1 yard of fabric left, and they really understand that they have 1 yard of fabric left if they use a model to represent it, versus if they just use the algorithm.
So that comes into along with create a story, and then you're using a fraction model. Okay, so if I look at, so this is kind of like an example. So if I look at like the knowledge base, like what they would need to know, they would need to know how to find or solve. They would need to know how to solve or compute dividing fractions. They would also need to know what quotient means. They would need to know what a quotient is, like know the definition of quotient.
Not only the definition, but what it represents. You know, that the quotient represents the parts or the groups, how many in a group or the number of groups. And then they definitely need to know what the dividend represents, so that is how much you have. And then
so they would need to know. So basically, going back to like when we were dividing like whole number, doing long division, they have to understand. So they need to understand the difference between the divisor and the dividend.
But not just one's called the divisor, one's called the dividend, but actually what they represent, I think.
So basically, they would need to know that the divisor is that's what you're dividing by. No.
Yes.
Yes, the divisor is you would want them to understand that the divisor is what you're dividing by. That's also what you are, and then the dividend, that's the number that you're trying to divide up into groups.
So the divisor really is the amount in one group.
Oh, okay, I get what you're saying. Like,
Mhm.
so the divisor is what you're dividing by because you want that amount of groups. Like, if
You
you're
amount-
dividing by 3, you want 3 groups. You want to try to
No.
break the dividend into 3 groups?
Well, you want to have that same amount in each group. You don't know how many groups you're going to have yet because the quotient tells you the
Right,
number of
okay.
groups.
All right.
So, or you're talking about like the length of the skirts. And so if you have 1.5, well, that would be 3 1/2 pieces that you would need to collect because that's your divisor. So that's the size of what you're cutting up, basically. For them to really understand that, I think helps them to build a deeper conceptual understanding, especially when they're creating a model.
Okay. So they would need to have a knowledge of fraction models if they're going to use them.
Mhm.
So they would need to know, I guess, would it be know how to use a fraction model?
Create.
Know how to create and use a fraction model. And then use a relationship between multiplication and division. So this is like just another example of the type of problems that they need to be able to solve. Okay. So reasoning, if I had to come up with like...
Sorry.
No,
With
you're
the
fine.
whole, this part too,
The
with
fraction.
creating a model, they
Mhm.
have to understand, if you're working with fractions, what the numerator represents and what the denominator represents.
So understanding the parts of
Mhm.
the fraction. So both the numerator and the
Mhm.
denominator. Which the numerator would be what you're trying, like ultimately what you're trying to split into groups, and the denominator are the amount that you want in each group. So basically
No, the
relating to that,
denominator.
or
The denominator is what you're, like, the denominator is what you're cutting, what the group that you're cutting, or it's better if I have an example. I don't know how to explain it. Like, you would think I'd be able to explain, but I have to draw it. So it has to be like,
here's one here.
right. So if you look at 3/4 divided by 2/8,
Okay.
right? So this would be the first bar, and then you would cut that bar into fourths,
Right.
right?
Right.
And then you shade in 3/4 because you have 3 out of the 4 pieces, and this is the whole. So this first number is not a whole. That's why we shade in 3/4, right?
Right.
But we still have to represent the whole, like one whole.
Right.
But you only have 3/4. And then the second one, so you do a second bar, and it's telling you that you cut it into 8 pieces, and you're looking for how many 2/8 fit into 3/4. So this would be 1, 2, 3. There are 3 2/8 that fit into 1.
Oh, okay. I was counting individually. I was
Right.
about to say 1, 2, 3, 4, 5, 6, but
There's
but
6
it's 2
1/8, but
there's
3
2.
2/8.
Okay. So my question is, when you are creating this, how do you know, like how do you know how many of these are supposed to go under this 1/4? Like, how do you know that you're splitting it up correctly? Like, if you're teaching them how to create it, like, what about those students that may try to, their boxes are uneven or something, so they end up putting 3/8 under just this one part of one?
Well, you kind of tell them that they have to be even. I mean, if this is fourths, then I usually draw my fourths first,
Right.
And then I'll say, okay, how can you cut this now into 8 pieces? And then you would just divide these boxes in half. So I first do these lines, like where the fourths would be under here, making the bars even, and then I'll go back and cut those in half to make 8 pieces so that they're even.
I get what you're saying.
And then also I would go ahead and label this as 2 eighths, 2 eighths, 2 eighths. And then I put one big giant line down here showing that this is the part that is equivalent.
Mm-hmm.
You know that you're looking for how many groups are in this much,
Okay.
the 3/4. Just to give them a little bit more idea than this, just so I try to label it a little bit more so that they know.
So
What
when
it's talking about.
you start with dividing fractions, you start with the visual aspect of it. Like you would start, like you wouldn't go into teaching them the algorithm first. You would help them understand what they're actually doing to begin with. So you're trying to split 3/4 into 2 eighths, and your answer is your answer is going to end up being how many times you could split this.
Or I say
the
how many
pizza
groups of 2 eighths
can go? Can you
can
pull
you
out
make
of 3/4?
Yeah, or fit into
Or-
3/4.
Okay. So would it be more proper to say pull out of or fit into?
Fit into.
Fit into.
I think. And so then I start with regular division first, showing them a model of regular division of whole numbers, and then I will show them a whole number divided by a fraction. So we'll model a whole number divided by a fraction, and then we model.
Do you use this type of?
Mhm.
So like if you had like 8 divided by 4, would you do like 8?
I might do it like that, or I might just do individual boxes.
So like drawing 8 boxes. Do you do it straight across? Or does it matter?
It doesn't matter really.
Okay.
And then divided by 4, and so we would circle the 4 pieces, and then we circle the other 4 pieces and label this one group and 2 groups. So 8 divided by 4 is 2. And then that helps them to kind of understand and transition into, okay, what if I had 8 divided by 1/2? Or 8 divided by 1/4, but we start with 1/2.
So once again, you would do 4, you would do 8 boxes.
And then I'd put, and so we're going to.
But you're dividing by 1/2.
1/2.
So you would cut each box in half, right? And so then how many groups of 1/2? And so then So you
you
would
would
need to
just
label-
number the little
So
boxes.
1, 2, 3, 4, 5, 6, 7, 8, 9, and then it goes to 16. So they would need to understand that you just made 16 groups. So 1/2 can fit into 8 16 times.
And then we might do 8 divided by 1/4 to see.
And then that would be you splitting the boxes into 4s like this. So each little box, so it would be 1, 2, 3, 4, 5, 6, 7, 8,
And then they'll see that you,
And then do you go any bit, like after you do 1/2 and 1/4, do you do like another one so they can kind of see their relationship, or do you just kind of stop there?
I kind of stop there. I mean, I might use a different whole number, but we usually, or I might do this and then they do it. So I'll give them a different number with 1/2 and 1/4, and then I'll pull their models and look at them under the ladybug.
Do you stick
And
with
then
even
analyze
numbers
them.
as far as whole numbers, or do you?
No.
No.
No, we'll use, so if I give them even numbers, then they do a problem with even numbers, then I'll give them a problem with an odd number,
And then
so
they
it's not
do.
the same. Because, those can be a little bit tricky when you have fraction pieces left over. So for example, the 10 divided by 1/2.
So you would do 10 boxes, 1, 2, 3, 4, 5. So divided by 1/2, that means you would have.
So I would divide each of those boxes, I put a dotted line down each of those boxes.
Down each of them?
Yeah. Now you can do a continuous tape diagram like that. I do the models differently. And so they would be creating groups of 1/2. So
That's
I would-
one whole.
right.
So it would really be like this.
Yes.
And then that actually goes with that,
Mhm.
which means that's like this.
Mhm.
And then this would go here.
Mhm.
And then you kind of have,
I
should
would-
probably did it next
I
to
would
each other.
no. I would like leave that, and then I would just start down here
Oh, okay. And
because
so
it's fine.
that means you have,
Because I would say,
this.
well, how many? 5.
and then you start over again, leaving you.
Yes. So then the answer is 6, but they have 2 pieces left over. So a lot of them think it's 2 over 2, which is 1, which doesn't make sense. But it's really, you have 2 pieces, and you have to think about the amount of pieces in your group. Like these are 2 pieces, and you need how many pieces to make a group of one whole?
You need one and,
You need
one and a
1,
half.
2, 3 pieces.
right.
3 1/2 pieces, right?
Mm-hmm.
So here you would have 2 left over out of 3 pieces. So it's 6 2/3.
Because you needed 3 1/2 pieces to
Mhm.
make 1.5.
Yes.
So you have 2 pieces left out of
The
3
3 pieces. Mhm.
because the 3 is what you need to create a group.
Yes.
So don't look at this as 1/2 and 1/2
Right.
because that's not what it is as far as grouping goes.
Well, it is a 1/2 and a 1/2, but you need 3 1/2s to make a whole, and you only have 2 1/2s. But
Out of the
that's
3 groups that you needed to make 1.5, or not the groups, out of the
3
3
pieces.
pieces that you needed to
Mhm.
make 1.
So this is like the number of pieces I have, and this is the number of pieces I need for my group, for one to get another whole,
I need.
right?
Right. Okay.
And so then it's 2 1/3. So, if we were talking about skirts, that would be like the 2/3 of a skirt, the 6 and
So
you
your
can't
best
make a whole
answer would
skirt.
be you can only make 6
6
skirts, and you would have 2/3 fabric left over.
Mm-hmm. 2/3 fabric or 1 yard, because this is 1/2 yard, 1/2 yard for 1 yard.
But
Yep.
the answer is not 7. The answer is
Right.
not. Okay.
It's 6.
Okay. So if we wanted to make, so even though this is one standard, if we wanted to make learning targets,
Mm-hmm.
it would be I am able to interpret the quotients of fractions. Would you do interpret quotients of fractions and solve word problems, or you would do interpret quotients of fractions and then have an interpret?
I don't know. I go back and forth on I know we need to use those words, but
Well, no, I mean
a
we can
6th
change
grader,
them
I
into
would just say,
so understand, or
I would say I can explain the meaning
interpret
and
so-
value of
and then compute. You would put
of a quotient.
what for compute? Would another good word be solve the quotient of a fraction, or no?
Compute. I can solve fraction division problems.
So
I mean, you could probably still use the word compute. I just think interpret sometimes would not have meaning for them. So to say that I can explain the meaning and value of a quotient would work better.
So reasoning would be, if we had to put it just in our terms, not necessarily kid-friendly terms, they can interpret quotients of fractions, and they can interpret, well, I guess that will all go together, interpret quotients of fractions and solve word problems
Mm-hmm.
involving division of fractions.
Mm-hmm.
And then they can compute quotients of fractions and solve
Mm-hmm.
word problems. And then I guess they should be able, and then another one would be they should be able to create a story in context using a fraction model. Would that be a standard, or would that be something that a learning target for them to be able to do this? Or should they be able to do this in context with the
I mean, I think you could put it as a learning target. I mean, if that's, I might put that as a learning target, and then I would but I wouldn't put them together. I would say
there would
that
be
I
separate learning targets, right?
I would say I can compute quotients of fractions using visual fraction models. Or I can create visual fraction models to compute quotients of fractions.
So let me ask you this. So performance process skill has been explained to me that basically they do it right there, like in front, like they have to, like for example, like PE, when they take their running test, that's a performance process skill because they're showing you how long they can run or whatever, how many miles they can run right there at that moment in present time. So this standard right here, there is no performance process skill because they're not doing anything at that moment to show you that they understand it. Like if you choose to have them create a story, as far as how you're going to assess them, that's different from a performance process skill. And then product, there's nothing that they're giving you. Like,
Are they not creating a visual fraction model?
So that could be considered
I would think
product
that was
or
a product and a performance skill.
So I guess when we were talking about it in class, that came up a lot, like as far as like how you assess them is different from actually what's in the standard. And when we were talking about performance process skill, like the main example that kept coming up was like PE and stuff. Like with PE, when you do a running test or they do a fitness test, they're performing the task right there in front of you in real time. But like if in math, if you have kids go up to the board and solve fraction problems, that's not necessarily a performance skill. That's just how you're choosing to assess whether they know how to solve the fraction
So
problem.
what would be an example of a performance skill according to your class?
Basically like performing something in real time.
Well,
The only thing I can keep thinking of is because that's what they brought up and that's what I understood is like the PE situation. Like if I perform a fitness test,
yeah, but
they have
that's
to do
PE.
fitness.
How did they give you an example in math?
We couldn't come up with any examples in that because a lot of people, including myself, started getting confused between how we choose to assess them versus what the standard
Well,
actually
so maybe a
says.
performance process skill would be something like, that perfect purple paint thing that I do is where they're learning in real time. Ratios or equivalent
and they are
ratios
performing, showing that they know
Right.
ratios because they're using the
But-
paint and stuff like that. So that
Right, so they're kind of developing their own understanding using concrete modeling
So for this
instead
one,
of just assessment.
I would say there's no performance process skill, but then I go back and forth as far as a product because if I'm talking about creating a story in context using visual fraction model, the product would be them creating
the performance skill.
or would that be that?
The performance skill is showing division if you're using manipulatives, possibly.
So the fraction bar could be manipulated. Like if you're using a fraction bar to show, like that's something that they do. Okay. And
Possibly, I don't know because I don't know what they're considering a performance process skill versus a product.
And then academic language, they would need to know. They would need to know quotient. They would need to know what division is. They would need to know what a fraction is.
Numerator,
They would need to know what a numerator is, denominator, divisor, dividend. And then, so if we're saying what type of learning target best represents the level of rigor, if it goes all the way up to product, then we know product is the type of learning target. But if it stops at reasoning, then we know reasoning is the best represents the level.